Hello and welcome to Venslope Academy. This is part 3 in our Wireshark beginners tutorial. In this lecture we are going to look at how we can analyze an handshake happening between us as a client and a server. We are going to learn shortly about the theory behind a handshake, what is happening, and then we are going to see one actually taking place using Wireshark so that we can analyze and see the different information being transferred. So first of all, what is a handshake? Well, a handshake is what is happening between you as a client and a server whenever you're communicating securely over TLS or SSL. But SSL is now outdated and TLS is the new and more secure version. But you will maybe hear SSL handshake, whereas it would probably be a TLS, but a lot of people is still using the old SSL word, but it will basically mean the same, as long as you of course are sure that you're using TLS as the more secure one. But let's get into to what is actually happening. So when you as a client communicate to a server, it could for example be when you go to Google. So you will send a synchronization request, and the server will acknowledge that and send a synchronization back, which you will acknowledge once you are sure that there is an active connection between you and the server. You're going to make a client hello, where you basically just initiate the handshake by sending this hello message, and this message will include the TLS version that you as a client support, because there are different versions and you and the server need to be communicating over the same version. So you'll be informing the server what TLS version you support, and then the server is based on your client hello is going to send a server hello in a reply, and that is going to contain the server's SSL certificate and the chosen cipher suit and used by the server. So based on that, you are going to make the client key exchange. So once you have received the certificate and the server has acknowledged your client hello, you're going to exchange the key from your machine to the server, and based on this, where you are using asymmetric encryption to make this communication, you are going to generate a session key such that you can, once the handshake is completed, use asymmetric or symmetric encryption. So let's see what the difference is between these two. So let's just get this up right here. So when we are talking about encryption, there are the symmetric encryption and asymmetric encryption. And the asymmetric encryption is what you use doing the handshake, where you are still not trusting each other and you are in need of figuring out what protocols and what key to use. So here you will be using the asymmetric encryption, where you have a private key on the client side, a private key on the server side, and then using the public key, which you can share between you, because there is no secret in the public key. Everybody can in principle have your public key because they can't use it to anything else, then encrypt a message that only you can decrypt using your own private key. So you're using asymmetric encryption during the handshake to share the information between the two of you, and once you have shared the information, you are going to generate what is called a session key, which is the symmetric encryption approach, where this is one key that is the same on both the client and the server side, which is used to both encrypt and decrypt information. And the reason that you can use this is because you are transferring this key and setting up the different parameters used for this using asymmetric encryption, because you can't generate a session key and just send it to the server without having it encrypted, because then if anyone in between you, for example using Wireshark, get access to this key, they will be able to pick up the messages transferred between the client and the server and then decrypt them using that key. So you want to transfer the session key using the asymmetric approach, and once both parties have the session keys set up, you can start make all the communication happening over symmetric encryption. And the way that you are authenticating that a given server is who they say they are is using the server certificate, which is issued to the server's domain. So for example, here we see the certificate for google.com, which is assigned to star.google.com, so all subdomains of google.com. And you can see the certificate chain right here, which prove to us that this has been signed by a trusted entity. So there is a common acceptance of who is able to sign certificates, and based on the fact that we trust these signing parties, we know that once we see a certificate that has been signed by this particular source, we know that we can trust that this certificate is real, because in general you could just create a certificate yourself, but without the right signing to that certificate, you can't be sure that it is actually a valid certificate on a server who is what they say it is. But if you want to know more about certificates and encryption, this is a very high level description of it. I recommend that you take a look at the network series here on Venslov Academy. You can see it on the top right corner here, and here we will dive a lot more into the depth of how certificate and signing and encryption is working over the net. But we will not be in need of this for this Wireshark beginners tutorial. So let's head back to Wireshark and see an actual handshake taking place. So here we are back in Wireshark. I'm going to pick my Ethernet interface. If you are not aware of what the interface is, what filters is and such, then please go watch the 2 previous episodes where we discussed these. So first of all, we are going to stop our capture right here. Then we are going to have a private browser open because we want to make a new handshake and be sure that there are no existing session key between us and the server. We are going to select Google. So we start a new capture, continue without saving, go back here, navigate to google.co, accept and stop. So now that we have arrived at Google and we are seeing that we have a valid certificate and we are actually communicating over HTTPS, we should now have been completing a handshake with the Google server. And as we see here, we have the certificate similar to what we saw before, and we have the signing path right here. So we will go into Wireshark first, and if you want to ensure that we only see, and because as you see there is a lot of information right here, but we only want the communication from Google, so we can just do a quick ping to Google, and then we will basically just copy their IP here. Then we just go up and select and this was the one, yeah. So we just select this IP, so we are using an IP address filter. So now we are only seeing packages being transported with either a source or destination of this IP. So as we see here, we have the client hello, which is followed after an acknowledgement here from us to the server to us, and then the final acknowledgement before the client initializes the client hello. So as you see, the protocol here is TLS 1.3. So this is the one we as a client greets the server with in our hello. And if we dive here into the information of this package here and continue down this path, we see that we are using the handshake protocol and we are initializing our client hello. So if we go into this one, here we see some different information, but what we are doing in our client hello, among other things, is to say to the server, this is the different cipher suites that I support, and if you want to see these, we can see right here. So here we are telling the server all the different suites that we as a client support. So this means that the server can pick between any of these in this handshake when communicating with us as a client. So here we are just saying, this is what I support, what do you want to use? And then we go to the next package which is of interest for us, the server hello. And let's just close this up so we start from the beginning. And here we see that the client or the server is initializing hello. And if we go into this one here, we see that the server is not communicating a different range of suits back to us, because we have told the server what we can support. So it's up to the server to select one that it does also support. So the server has chosen that we are going to use the TLS AES 128. So this is the cipher suit that we and the server are going to use based on what we sent in our client hello. So this is the server saying hello, and it tells us about the cipher suit that we are going to use. So following this server hello, which we can see is coming from the server due to the source IP being the Google IP and the destination our client IP, we are seeing that application data is being transferred as well from the server to us, and this is now in an encrypted state. So based on our client hello and the server's information that has been sent, the server is now sending us some encrypted data that we are not able to interpret without having the key, session key and the public key from the server, because now this is being encrypted. And then we see here that we as a client communicate back to the server that we acknowledge, and from this point on, where we again send the last cipher specification from us as a client to the server, we now see that application data is more or less the rest which is being transferred here. And in the encrypted application data here, it is basically rubbish to us to read, because we can't read encrypted data. And that is the whole sense of the handshake, that the information transferred between us as a client and the server is now being encrypted. So if we want to see the data that is being transferred here, we can unencrypt this using the session key that is generated. And we are going to look into that in the part 4. So stay tuned for the next video, where we'll be decrypting this and demonstrate how this can be done. And then remember to like and subscribe, and I will see you in the next video here on Winslow Academy.